Welcome to The Explainer. Today, we are stepping right into the high-pressure environment of Cambridge AS and A-level information technology. Specifically, we are cracking the code on Section 4.1, which is all about decision-making algorithms. If you're studying the 9626 syllabus, you already know that algorithm design can literally induce a cold sweat when that exam timer starts ticking down. It feels like a newsroom on deadline. The pressure is immense, you have to break down a massive story, or in this case, a complex question, and you absolutely must deliver the headline. You need the exact right answer. But today, we are completely transforming this topic from a massive point of anxiety into your ultimate secret weapon. Imagine two types of students taking this exam. First, there's Alex. Alex overloads every single answer with raw computer science facts, but includes absolutely no analysis. Then there's Sam. Sam rushes the paper, completely missing the command word requirements and throwing away easy marks. By the end of this session, you're going to know exactly how to avoid the traps that snare Alex and Sam and secure top marks.
Okay, let's dive right into this and ask the absolute ultimate exam question. What actually separates an average B grade from a top-tier A star? I'll tell you right now, the difference doesn't come down to simply knowing more programming code or memorizing an encyclopedia of facts. It doesn't work like that. It comes down to exactly how well you understand the specific expectations of Section 4.1. Alex knows every fact in the book, but Alex gets a B. Why? Because the A-star student knows how to deconstruct the problem. Today, we're not just going to show you what the examiners are looking for, we're going to show you how to structure your thinking so that the examiner has no choice but to give you maximum points.
We are going to treat the examiner's expectations exactly like a puzzle that needs to be systematically decoded. Our battle plan covers 6 key areas today. We will start with a grade difference hook, move right into the core principles in logic, break down the actual technical methodology you need, explore critical analysis and evaluation, reveal the top examiner warnings directly from the source, and finish strong with a winning strategy recap. Let's move straight to Section 1. We need to completely shift your mindset before we look at a single piece of code. It's time to completely redefine what a good answer actually looks like to the person grading your paper. This brilliantly illustrates the ultimate academic benchmark. The assessment framework heavily, and I mean heavily, prioritizes analytical depth over just dumping superficial facts onto the page. Let's think back to our student Alex. Alex relies on superficial breadth. Alex dumps a million scattered puzzle pieces of raw facts onto the paper. That gets you a B. It shows you read the textbook, sure, but nothing more. Analytical depth, on the other hand, is showing the gears turning in your head through logical, structured reasoning. This is where top students use frameworks like peel, point, evidence, explanation, link. They don't just state a fact, they analyze it deeply. The examiners want to see your brain actively working on the page. They want proof that you can analyze a problem systematically, not just broadly list what you memorized last night. So everything we discussed today centers entirely around Syllabus Section 4.1. Whether you're looking at 0417, 0478, 2210, 9618, or 9626, this specific section on writing and editing algorithms is designed to target 3 distinct cognitive domains. It tests your underlying knowledge, your practical application of that knowledge under deadline pressure, and your high-level analytical skills. You absolutely have to hit all 3 of those targets simultaneously to max out your score potential. Let's move into Section 2. Now, what is really interesting about the core logic of this exam is how you are actually rewarded for your thinking process, not just your final destination. Before we continue, subscribe to our YouTube channel, Ace the Exams, at acetheexams_IGCSE to excel in your Cambridge examinations. Click that subscribe button and hit the bell icon right now. Okay, let's look at the theoretical foundations that govern exactly how these algorithms are assessed. This right here is the absolute game changer, the method mark strategy. Look, multi-stage analysis is notoriously hard for students. You get into the exam room, the clock is ticking, and it is so tempting to just rush to the final answer like our student Sam does. But this scoring system means examiners desperately want to see your evidence-based reasoning on the page. They are literally rewarding you for how you arrive at the solution. If you only provide the final output of an algorithm, but you completely skip showing the systematic analysis that got you there, you are leaving massive, massive points on the table. You have to prove the journey, not just the destination. To absolutely secure those top method marks, your theoretical architecture has to rest on these 3 solid pillars. First, you must establish precise definitions right out of the gate. Second, you have to map the causal relationships. You need to explicitly show what happens and why it happens in the algorithm's logic flow.
And third, this is a massive insider tip straight from the people marking your papers. Highlighting cross-topic connections is a proven way to achieve significantly higher marks. If you can show how a decision-making algorithm impacts data privacy or hardware constraints, you instantly demonstrate a top-tier understanding of the entire syllabus. Knowing the theory is a great start, but let's pivot and look at the actual procedural framework you need to deploy when the clock is ticking and the pressure is on. This is your practical, step-by-step toolkit. When you are tackling an exam question, you need to rigorously follow this 5-step workflow to ensure you are meeting the incredibly strict conventions required by examiners. Think of this like a speed writing checklist. Step 1, deconstruct the question. Do not rush this. Step 2, extract only the relevant data. Step 3, select your analytical framework, like the Peel structure we mentioned earlier. Step 4, execute your logic with perfectly clear notation. And Step 5, present your findings using the correct professional terminology. If you skip a single step here, you skip a mark. It's really that simple. Right within that workflow, your data interpretation skills are absolutely critical. Imagine you have a 60-second visual countdown timer to scan a complex computer science chart or data table. You must be able to pull highly specific insights from those provided texts. Don't just blindly copy the data over. You need to interpret how the different variables interact within the algorithm, and then use that exact interaction as the concrete foundation to draw hard, evidence-based conclusions. Now we are moving to section 4, and this is where we separate the good from the great. Stop scrolling. Subscribe to our YouTube channel, Ace the Exams, at @acetheexams_IGCSE to excel in your Cambridge examinations. We've helped thousands of students improve by 2-3 grade boundaries. Join them right now by subscribing to @acetheexams_IGCSE and turn on all notifications so you never miss our weekly exam strategy sessions. Let's elevate this further and explore the higher order assessment objectives that really unlock those A-star boundaries. This builds into a beautifully simple, highly effective problem-solving loop for Section 4.1. It starts with deconstructing the given information into logical, bite-sized steps. Then you solve systematically. But the real magic, the absolute key to top marks, happens in Step 3. Evaluate. You must actively check your algorithm for reasonableness. You have to make justified recommendations. This evaluation phase is exactly what proves to the examiner that you truly understand the real-world implications of the decision-making process, not just the code on the screen. Let's play a quick game of Find the Flaw. When you are asked to do a comparative analysis between different algorithmic approaches, a huge flaw is just listing features side by side. That loses marks. You must identify both similarities and differences. To do this properly, you need to use comparative connectives to actively contrast them. Words like whereas, conversely, or in contrast. You must support each comparative point with specific evidence to draw clear, undeniable conclusions about their relative importance. Top-scoring candidates constantly demonstrate this intense level of evaluative thinking. They never just accept the given scenario at face value. They proactively question the underlying assumptions of the algorithm. They consider different perspectives, alternative solutions, and edge cases. And most importantly, they ensure every single recommendation is backed up by evaluative, hard evidence. That means you are using specific data paths or logical constraints pulled straight from the scenario rather than relying on vague, generalized opinions. Now for some highly valuable insider intelligence. Let's pivot and look at exactly where students are losing easily preventable marks, straight from the people grading your actual exam papers. This quote right here is a massive red flag straight from the principal examiner reports. Candidates consistently confuse key terminology. Listen, you simply cannot assume the examiner knows what you mean or that they are going to graciously give you the benefit of the doubt. They won't. So the absolute non-negotiable rule here is you must explicitly define your terms first before you deploy them in an extended algorithm response. Break the story down before you deliver the headline. Make absolutely sure you memorize these top 3 mistakes from the examiner reports. First, students frequently confuse cause and effect in their logic. Second, like our friend Sam rushing the exam, they completely forget to check their format, presentation, and clear annotations. Remember those strict conventions. And third, just like Alex, they provide generic textbook answers instead of actually applying their knowledge to the highly specific context given in the exam scenario. Here's a great memory hack to mentally check your work under pressure. Use the mnemonic, cats forget grammar, for cause, format, generic. When the clock is winding down, that silly phrase might just save your grade. Okay, we have covered a massive amount of ground. Let's bring all of this together into one cohesive, foolproof battle plan for your exam day.
Consider this your ultimate cheat sheet graphic. If you lock in these structural strategies, you will drastically elevate your mark potential all the way to 100%. Always chase some method marks by showing your incredibly systematic process. Use the deconstruct, solve, evaluate loop for your critical analysis. Consistently apply precise terminology with the exact correct formatting conventions. And finally, build those cross-topic connections to show the examiner you have true analytical depth across the entire syllabus. The choice between a B and an A star is entirely in your hands. On exam day, will you fall back on superficial breadth, like Alex, or will you command the method marks with logical, structured reasoning? Students who implement these computer science strategies see an average improvement of 2 grade boundaries, but only if they practice consistently with our weekly videos. Here's your final reminder. Subscribe to our YouTube channel, Ace the Exams, at acetheexams_IGCSE to excel in your Cambridge examinations. Subscribe right now to @acetheexams_IGCSE and click that bell. Don't let another exam pass you by. Drop a comment below with your target grade for computer science and the biggest challenge you're facing. Our team responds to every comment. Like and share this video with a study partner. Ace the Exams, your Cambridge success starts here.